The next rule consider by different bases to the same power. So we look at, for instance, a times b, which can be 2 times 3 or something like that. So let us write it out first. If we look at a times b to the power of n, then it actually means that we have a times b, but if we continually gather all the a's together and all the b's together, we know that we have the commutative law and distributive laws and associative laws, etc. So we can write all the a's together and we can write all the b's together, like that. But we know here we have n times. So the number of a's did not change. There are still n times the number a, and there are still n times the number b. So that we can write short a to the n and short b to the n. If we simply just look at an example, for instance, suppose we have 2 times 3 to the power of 4, then we can say, okay, but this is equal to 6 to the power of 4, which is 6 times 6 times 6 times 6, which is equal to 36 times 36, and if we calculate it, we see the answer is 1296. But we can also just write 2 times 3, 2 times 3, 2 times 3, and then from that we can reverse the order, swap it around, and gather all the same bases together. And then we see we have 2 to the 4 times 3 to the 4. So the rule applies. It just says, remember that here we don't write it, but there's actually the number 1, exponent 1. And so in this case we say 4 times 1 and 3 times 1, and we get the answer that we have here, 2 to the 4, 3 to the 4. So in the case where we have different bases, then we just distribute the exponent over the different bases. We can apply it to anything, like, for instance, suppose we have minus, I'm just going to change the color. Suppose we have minus 2x to the power of 3, that we will have minus 2 to the power of 3 times x to the power of 3, in which case we will have minus 2 to the 3 x to the 3, because here we have 3 minuses, the minus 2 to the 3 is the same as minus 2 times minus 2 times minus 2, which gives us 3 minuses and a 2 to 3. Good, so that is this rule. So let us look at the next rule. In this case, we have a already to the power of m and then raised to the power of n again. So on the left hand side we have a to the m times a to the m times a to the m a to the m n times. So if we use the power rule, we will have, if I use the sum rule, I will have a to the m plus m plus m n times, and that we know is just a to the m times n, because it's like 2 plus 2 plus 2, that is 3 times 2. So it's the same thing. So if I do look at an example, then we have something like, say 4 to the 2 to the 3, that will give me 4 to the 2 times 4 to the 2 times 4 to the 2, which will give me 4 to the 2 plus 2 plus 2, which is equal to 4 to the 3 times 2, which is equal to 4 to the power of 6. So, and we will just use the rule, multiply the exponents, and then write the answer as 6. So that's a short way to do it. If you understand what this a to the m means, then it's very easy to remember the rules, and if you then get confused, you can just go back to what does it mean if I write a to the x? What does it mean? And then we go back and apply our rules.